Good morning everyone and welcome to today's webinar. So today we will be seeing what's new in Solid Edge 2023 and this is the second part. So the agenda for today's webinar includes all the new assembly features that were introduced in Solid Edge 2023. So we have the new Swept Cutout command, we have a new union command and a slot command as an assembly feature. And then we have some enhancements made to the assign capture fit. After that, we will take a look at all the enhancements made in the simulation environment, which includes the mesh element quality check, the assembly body mesh option, and the option to reuse the existing mesh. And at the end, we will take a look at the enhancements made to the design configurator, where we have the ability to add draft files inside the configuration. And also we have the new option to place part as a model action. So as you can see from the screenshot attached here, we have some new assembly features, that is the swept cutout, the union and slot, and there are some enhancements made with respect to the subtract command. So the enhancement made with respect to this subtract command is that in the previous versions the subtract command was only available for frames, but now you have the option to select subtract command for any of the assembly features. So the first one is the swept cutout command. So the workflow to create a swept cutout as a feature in the assembly is still going to be the same as you would do in the part environment. You have the option to select single or multiple path and single or multiple cross sections. Then we have the slot feature. So inside the slot feature, the options are same as you would see in the part environment. You would have to select the sketch first and then options. Inside the slot options, we have the option to decide the end conditions of the slot. We have two options, that is the flat end and the arc end, and then we have the option to decide the slot width. And then finally we have the union feature, which is the Boolean operation which is used to combine selected bodies into a single body. So let's take a look at all these features in action. So here I have an assembly, as you can see from this in the application here. So the first one that we are going to take a look at is the swept cutout as an assembly feature. So like I said, the workflow is still going to be the same, where you would first go to the command, and this options window shows up where you have to select the type of path and cross section. So in this case, let's say multiple path and cross section. So the workflow here is first you would select the path, and then you would select the two cross sections. So we have a circular cross section and a square cross section. And once you do a preview, the third step is where you decide the body selection step. So this is the body from which I want to create a cut, and after hitting the green checkbox, you will see that you get this swept cutout along the path that you just selected, which starts as a circle and then ends as a square. So this is how you do when you have multiple path. I mean a single path and multiple cross section. So in case when we have a single path and single cross section, the workflow for that is still the same. You would go to the swept cutout feature, change your sweep type to single path and cross section, select the path, select the cross section, and then select the bodies to cut from, so number 1 and 2, and that gives you a nice cut, as you can see from the screen here. Let me just hide all these sketches so that we can see it clearly. And then finally, we will take a look at the slot command. So inside slot command, we have this one more sketch which will help us to demonstrate that. So for slot command, again, you need to have a sketch. So you would first select the sketch that you have. Then you also have the option to decide the end conditions. So I want to use an arc end with a slot width of say 2.5 mm. Save it, and then you can have it as a preset here. The second step for slot is where you decide the extend step and then select the bodies to cut from. So this is how you can see that the slot has been created on the bodies that you have selected. And next we have the union command. Like the name says, it is used to combine multiple bodies and convert that to a single body. So here I would go to the union. First step is to select the target step. So this is going to be my target step, and then the two side plates here are going to be my tool step. So once you finish, you'll see that nothing much has changed here. But one thing you would see that inside Pathfinder you have a new option called as a union. So this is a new feature that has been created, and once you hide the two side plates, you can see the underlying geometry. So this is how you can use the union command as a feature. So the enhancements that were made to the assign capture fit feature is that in the previous version you could only assemble the parts using the assign capture fit feature, but now you can also assemble the sub-assemblies into a top level assembly using the assign capture fit feature. So let's take a look at this in action. Here I have this engine block, and I want to place a shock absorber assembly at multiple locations. So as you would normally do in the part environment, same thing you would do in the assembly environment. You would go to the assign capture fit feature, create the relationship group, and assign all the necessary mates. So once you do that and go back to the top level assembly, simply pull the part from the Pathfinder and then select the location where exactly you want the sub-assembly to be placed. So as soon as you bring in the part, you see that the software identifies that the mates have been assigned using the assign capture fit feature, and then you can simply select the location and the sub-assembly will be placed at that specific location. So this is how easily you can have your sub-assembly at different locations with just a single click. So this is one way of using the assign capture fit feature. So let's take a look at some other ways that this can be achieved. So I'll go back to the parts library, select the sub-assembly, bring into the active workspace, and this time let's save us some more clicks. So now when you go to the assemble modes, make sure you have auto assemble selected, and now all you have to do is just select the identify targets. So once you do the identify targets, you'll see that the sub-assembly automatically snaps at all those locations, and once you hit accept, the sub-assembly will be placed at all the 3 locations. So this is how you can save a lot of time and increase your productivity by unnecessarily not doing the repetitive steps. Now let's take a look at the new enhancements made to the simulation environment. First, we have the option to check the element quality. Solid Edge now comes with 14 Nastran element quality checks, as you can see from the screenshot attached. Here we have the option to check for warnings as well as errors, which are failed elements. So whenever you run a show element or you check the element quality, you get a report summary, as you can see from the screenshot, which gives you the number of failed elements based upon the criteria. So let's take a look at this command in action. So this is the sheet metal file I have here, and let's start a new study. So since I already have a mid surface made for this sheet metal file, we can directly skip the application of loads and boundary conditions since we are focused on meshing of the model. So let's go to mesh, change the element quality, let's make a little bit finer, turn on the body mesh, and once you perform a mesh, on the right side, as you can see here, we have the option to check the element quality. So once you turn it on, we can change that from only errors to warning and errors. So here, since uh, we have only surface, in that case only the quadrilateral and triangular mesh options are turned on. Say for example, if you had a part file, you would have the option to change the aspect ratio Jacobian for the tetrahedral mesh. So here, once you turn on the warning and error, you get the option to change the default values. So let's change the taper from 0.3 to 0.1. And once you do a show element, you get a report summary, which will show the number of failed elements and warning elements for the given model. So we have 7 failed elements due to quadrilateral warping, 9 failed elements due to quadrilateral taper, and so on. So you get all this report once you perform a check element quality. And also in the results tab here, you can see the total number of failed elements and the total number of warning elements. So this is how a user can quickly check the element quality for given mesh. So here you can simply go back to the mesh, make it a little bit finer, and once you remesh the model, you can go back and perform the same element quality checks that we just did. So let's go back and do show elements. So here now, as you can see, we slightly have some different results than the previous run that we just did. We have increased number of failed elements, but less but we definitely have less warning elements. So you can play around with this stuff and check for the element quality for any given operation that you do. So this is a new enhancement that has been made inside the simulation environment. Next, we have the ability to add the body mesh in assembly and the sheet metal environment. In the previous version, the body mesh option was only supported for part environment, but now we have the ability to add it for the assembly and sheet metal environment. So let's take a look at this command in action. So as you can see here, I have an assembly file, and inside the simulation tab, we already have the necessary loads and boundary conditions applied for this model. So let's go ahead and start by creating a mesh. So for starters, let's keep the body mesh option turned off and quickly create a mesh, and then we will be comparing this option, the mesh with the body mesh option turned on. So that can quickly be checked with the help of the new option that we have, which is the check element quality. So once you do show elements, it will give you kind of an information about the failed elements and the warning elements. So as you can see here, we have 13 failed elements. So let's go back. Let's go a step back, delete the existing mesh, and recreate a new mesh with the body mesh option turned on. And now once this mesh is ready, quickly we will perform an element quality check, and then we will be comparing the results, how body mesh can be useful to create a finer mesh in the very critical areas. So even by taking a look at this model, you can see that the mesh seems to be improved. But still, let's go ahead and do an element quality check for this model. So as you can see here, we have no failed elements or any warning elements. So this is how a body mesh option can be used in assembly and sheet metal now to create an improved mesh. So the next enhancement that we have inside the simulation environment is that the ability to copy the mesh from one study to another. So now when you create a duplicate study, the software is going to ask you with a question if you want to copy uh, the results with the mesh or without the mesh. So let's take a look at these options. So here I have a part file ready, and let's go and start by creating a new simulation. For this one, we will be applying some loads and boundary conditions. Let's fix this one feature right here. And apply a normal load on one of the faces. Let's do 1, 2, and 3. Flip the direction of the force, and let's use 100 Newton as the force. Next step is where we go and start by creating a mesh. And once the mesh is ready, we will solve the model. This should not take a long time since this is a very simple part. Okay. So once we have the solution, you have the option to animate the results, check different values like stresses, displacement, and so on. So now let's go a step back and create a duplicate study. So you go to static study 1, right click and say duplicate study. So now that you selected the option to duplicate study, you get a new option here, which is, do you want to create the copy with the mesh? So I'll say yes. So now you have your new study ready with all the loads and constraints, and also the mesh. So now let's say in our new study you would like to change the angle of the load, so that can be easily done as well with the help of the steering wheel here. So let's change it by 135, and now again solve the model. So this saves a lot of time for the user to recreate the same mesh on the same part. So this is how a user can save a lot of time by creating a duplicate study. So as you can see here, we have two different static study results with the change in the angle of force. So this is how you can reuse the existing mesh from the previous study to a new one. So now let's take a look at all the enhancements made to the design configurator. So first we have the ability to add the draft files inside the configuration process. The two conditions that need to be met are the name of the file should be same as a part file, and the location where the part file and the draft files are saved should be the same. So if you go ahead and right click on any one of the draft files, you get two options to either open the draft file or find out the location of the draft file. And when it comes to the model actions, we have a couple of options. We have the options to update the views or layers, show or hide the layers, and then we have the option to save as a model, and then we have the option to set property and set variables. So let's take a look at some of these in action. So here I have a sauna room assembly, and as you can see on the right hand side, I have all the part files that take part into configuration, and just next to the part file you have the draft file for that same part. Like I said, the name should be the same as the part file, and once you do a right click, you can either locate the file or open this file in a new window. So this is what it is going to look like once you open this in a new window. And when it comes to the model actions, in step number 4, if you expand this, you'll see all the part files on the top and all the draft files on the bottom side. So if you come and select any one of these, you'll see a couple of model actions. You have the option to set variables, set properties, save as a model, and update the draft file. So when it comes to setting properties, one useful thing that I see here is changing the title blocks for the draft file. So if you come to the expressions here, you can have an if statement ready for you, where you can simply define an if statement stating that when which in this case is that when you change the input material to aspen wood, the title block will say natural aspen wood, and when it's or else it is going to say heat treated aspen wood. So this is how you can you have the option to make if statements and change the title blocks. Apart from that, when it comes to updating the drafts, you have two options. You have the options to update the views and layers. In this case, if you go ahead and open the expressions tab here, you'll see that you have an if statement stating that when the input corner is centered and the input bench type is suspended, you want to hide the ISO layer, hide the bench layer, and show the suspended layer. So minus sign before the word is an indication to hide that layer, and plus sign means you would like to show the layer. So this is how you can create if statements and update the draft layers as well. So these were some of the enhancements made with respect to the draft files. And now for the last one, we have the new place part model action inside the design configurator. So whenever you would generally place a part inside the active workspace, the part would get placed with respect to the base coordinate system. But now with the new place part model action, you can choose which coordinate system you want to place it with reference to. So there are two different positioning modes, the matrix mode and the relative position. So let's take a look at some of these. So as you can see from the screen here, I have two different coordinate systems. I have a base coordinate system, and then I have a test coordinate system. So once you go to step number 4, inside the model actions, you have this new model action called as place part. So for starters, you would first point to the specific location where your file is located. So you can simply browse to the folder and select the one. So in this case, we have this bench, And the next one is where you define all the input fields. So here first you have the base assembly, that is the place part, as you can see. Then the model which is going to be placed, which is the bench assembly. Then you can decide which is going to be a base coordinate system. Since we saw that we have two different coordinate systems in the main assembly, for now let's use the base coordinate system, and let's define the relative position. So I already have defined all the input fields here, so I'm just going to select all those input fields. So for input fields I have X, Y and Z, and then I have them defined in the angular position as well. So you simply have to select all of those. So once you select all the input fields, you simply have to go to the last step. So here I'm just going to use the default values that just show up here. So let's do 0, 0, 0 and 0. So once you hit create, you'll see that the bench gets placed exactly at the base coordinate system. So, so as you can see here, the base coordinate system for the bench and the assembly now coincide. So let's go ahead and restart the configuration process. Let's go back to step 4. So instead of creating a new one, I can simply do a copy paste. And this time let's change the base coordinate system from base to test. Keeping the same input fields, let's see how exactly is the configuration process affected. So now here you'll see that the base coordinate system for the bench now coincides with the test coordinate system for the assembly. One more thing that you can see here is that in the bench assembly we also have two different coordinate systems. One is the base and one is the leg. So let's say if you want to coincide the leg coordinate system with the test coordinate system, that can be done as well. So let's restart the process, go back to step 4. Let's make a copy of this. And now here, or in order to achieve that, we have something called as the model coordinate system. So here make sure you enter the correct name, that is leg, and hit OK. So keeping the same input fields again, you'll see that now the leg coordinate system of the bench coincides with the base coordinate system. So this is how you can place the model with respect to different coordinate systems that you might have defined inside the design configurator. So that was the last point I wanted to cover. Thank you for attending the webinar, and let me know if you have any questions